Kumit, Eyabduk. Huh? Wait, sorry, that's my outro slide. I think I'm still in reverse. Anyway, there we go. Hello, Demuxed. Thanks for having me back. And look, I even brought some professionally looking slides this time. So I'm Mattias. I'm once again going to talk about making a video player on the web, but this time I'm making the player go backwards. Now, why wouldn't we need this? Like, video should just go forward. Why do we need it to go backwards? Well, for video editing, it'd be helpful if you want to find the exact frame that something happens to mark the start of a clip, to go backwards and forwards for a bit instead of like repeatedly seeking all over the place. Or if you're a video-assisted referee, you may want to find the exact frame when an attacker kicks the ball and then draw an imaginary white line over the field or something like that. I don't know how the offside rule works. Or thirdly, you may want to make funny GIFs, which are funnier in reverse. Like they have a green tongue. And that's the reason why the internet exists, after all. So, isn't this already possible? Well, if you ask MDN, it says that if the playback rate is negative, the media is played backwards. So, problem solved. Well, yes, but actually, no. If you scroll down that page, you get to the browser compatibility, and for Chrome it says, well, setting the playback rate to a negative value will throw you an error. So, well, that's just Chrome. Maybe we have better luck in another browser. Okay, let's hope for Safari. That says full support, so maybe Safari works? So here's Safari. This is a video playing directly in Safari. This is just playing forwards. I'm now using the console to put it backwards with playback rate -1. And okay, this is more of a slideshow. This is not really playing backwards, I'd say. So valiant effort, but no, this doesn't count. So now what? None of the major browsers support reverse playback, so are we out of options? Well, if we can't use the browser's video element, then maybe, just maybe, we can make our own video element, right? Yes, I am bringing back Baby's video element for a second iteration this year. Love it. If you missed my talk last year, or you've erased that from your long-term memory, here's a quick recap. So Baby Video Element is an HTML custom element which implements part of the Video Element API with like play, pause, current time, events, all that sort of stuff, along with the Media Extensions API. So you can do add source buffer, append buffer to it, and have streaming playback that way. It'll parse your FMP4 into individual video frames. It'll then decode those frames using the WebCodecs API, and it'll render those video frames to a canvas for display. Now, we are going to make this player go backwards. We need to do 3 things for that. We need to buffer in reverse, we need to decode in reverse, and we need to render in reverse. So, step 1, buffering. In a normal player, this is what your buffering loop looks like somewhat. If you have enough buffer after your current time, you're good. Just wait a bit, don't need to do anything just yet. If you don't, you need to find the next segment that goes after your end of buffer. You download and append that. And if it's the last segment, then you're done buffering. Otherwise, just repeat, go back to the top, and get on with the next segment. We want to do this in reverse, so we just replace a couple of things. We need to check for enough buffer before current time. We need to find the previous segment, and when we're done, we're only done when we reach the first segment. So this way, we'll buffer from the back of the video all the way to the front. Great. So we've got that. We have appended our FMP4 segments. We've parsed them into individual frames. Now we just need to decode them in reverse. So start with frame 6, run that through the video decoder from WebCodecs, store the resulting decoded frame. Then we just do frame 5, frame 4, frame 3, and so on. Right? Should work. Wait, that's weird. I didn't put this slide here. I guess I should warn you that there's going to be flashing images on the next slide. That doesn't really bode well for my video player, though. So here it goes. We'll put the player in reverse mode, and then play, and oh god. Yeah, no. That's not how I remember it. We've all seen those green frames before, and they haunt our nightmares. So let's get rid of that. So what went wrong? Well, the video consists mostly of P frames and B frames, and we cannot decode those independently. There's this thing called interframe prediction, which uses like motion vectors, and we can't just reverse that to get reverse decoding to work. So within a group of pictures, we actually have to send the frames in their original order. We can still change the order of the GOPs though. So that would look like something like this. So our sixth frame is actually in GOP 2. So to decode this, we need to first decode our keyframe, frame 4, and then decode the others in their original order, and then we'll get on with GOP 1. Keep those in our decoded frame buffer. Now, the only thing that's left is rendering. So on every animation frame, we decrease the current time by the elapsed walk log time. We find a frame on that current time, and we draw that to canvas. Now, the decoded frames are in a slightly different order, so we have to look a bit further in our list, but that's all doable. So then that looks something like this. And that is a reverse playing Big Bug Bunny. Like, look, the butterfly is going backwards. Bug Bunny has never seen this before. He smells some flowers in reverse. Like, great, that works. So we got this thing working, but we've encountered some challenges along the way, and that impacts some of the performance of this thing. For example, we need to keep the entire group of pictures in memory, because the first frame that we decode is actually the last frame that we want to render out of that GOP. And the GPU can only hold so many fully decoded video frames in its video memory. So when we actually have to copy those frames out of video memory and back into it when we need them, which is slightly less efficient, but hey, at least it works. We got it working, which is the main point we're trying to make. When we finally render that first video frame, we should also have that next frame ready, which is actually the last frame of the previous GOP, if you're still following along. So we need to make sure that we have at least 2 GOPs fully decoded by then, which again puts some pressure on the memory. This is usually not a problem if you have a desktop device with plenty of RAM, but it might not play as smoothly on lower-end smartphones. You can try downloading RAM or something. I guess that's what you're supposed to do then. As a bonus, I've also made this thing play audio. I don't really have a use case for this. It's just for fun. It's much simpler than video. Audio frames, you can decode those fully independently, and then we also need to make sure that each frame actually contains multiple samples, so reverse those as well if you want it fully reversed. We use web audio to render these. There's the audio buffer source node, which you can give an audio buffer and it'll play it for you at a set time. So we can schedule things slightly in advance to avoid leaving gaps, and we can concatenate multiple audio frames to reduce the number of nodes that we use. Ideally, you'd use audio worklet for this. I didn't get this to work yet, but maybe future work. And this is what that looks and sounds like. There's a bit of a crackle if you're listening on this in the live stream. So maybe I should really give audio worklet a try, but at least we get the good ending of Big Bunny because the butterfly lives again. Glorious. So there you have it. If you want to toy around with this, you can scan the QR code, go to my GitHub profile, it's all there. Thanks for listening. Oh, and if you're still watching this talk in reverse for some reason, Skumit, hello.